Hello, everyone. Welcome to the second session of Blue Cloud Hackathon 2025. We're going to just wait another minute as attendees are still coming in, and then we're going to start with this session. It's a pretty packed agenda today. We're going to be introducing you to all the VLabs that you're going to be using. We have with us many mentors and coaches that are going to be supporting you, so we're very happy to introduce them to you as well today. We are going to start with some house rules first. So just to let you know, we are going to be recording this live session as well. And then we're going to make it available to all participants on the Event Tornado platform as soon as it's ready. You can submit all of your questions through the Q&A. We will be answering them during the Q&A session. If some of them are more particular, we will answer directly in the chat. If we cannot get to all of your questions during today's session, if we run out of time, we are going to reply to all of them also in the hackathon channels on Discord that you have all signed up to. And of course, as always, we will try to definitely be done by 5 p.m. We understand that it is the end of a workday for many, many people, and we also have many different timelines. So we're going to try and be as timely as possible. We're going to get right to it, and we're going to go directly to VLab number 1, which is going to be presented by our Blue Cloud colleagues, Vânia, Lima, João, Vitorino, and Juan, Gabriel, Fernández, Pineda. They are also going to be, as mentioned previously, they are part of our coach and mentor teams, and some of you are going to be working quite closely with them. So it's a good opportunity to get to know them a little bit, see what work they have to present from VLab 1 and ask all of your questions today. So I'm going to ask, I think we're going to start with João. Hello, João. Thank you again very much for joining us.
Thanks. Let me share then my presentation.
Indeed.
Okay. So I think you can see the presentation, okay?
Perfect.
Okay.
Thank you.
So good afternoon. Thank you very much for assisting. Let me rapidly present the VLab 1. So it's the integration of coastal ocean observations along Europe. I will be present part of this virtual lab, some 2 thematic services, and then my colleague Juan Gabriel Fernández from SOCIB will present the third virtual lab. So this virtual lab is being developed together by Instituto Hidrografico in Portugal, SOCIB in Spain, and ICOOE in France. The main aim of this virtual lab is to support coastal ocean researchers and other more general users in the identification, access, and processing of the available data and other relevant complementary information for the coastal ocean areas, and in the analysis, integration, visualization of this broad information. We are proposing 3 thematic services. Thematic service 1 is focused on the transboundary transport and connectivity processes. We want to explore and to better understand the different processes that in the coastal ocean areas are able to long distance transport water properties, disturbances, and contaminants and biological species, so promoting connectivity. And the strategy for this thematic service 1 is to allow the users to identify and access the observations and other information that they think are relevant for the problem that they want to explore, connecting them to the aggregators that made available this data, and then continue to the integration, to the analysis and integration visualization of this data. The pilot demonstration is being applied to a specific geographical domain, the Iberian coastal ocean area that you see here. And in this area, we have a number of monitoring infrastructures that are provided by institutions in Portugal and Spain, and that are available through a number of data aggregators. We also in this pilot concentrate in the surface currents, either measured by HF radars, and in this case, we are using the data that is available in the European HF radar node, or surface currents that are the result of the numerical simulations in models that can be accessed through the Copernicus Marine service. The interface with the user is through a dashboard environment where the user can see the main geographical area, where he can select the geographical domain of interest for their research, where he can select also the time period of interest for the research, and also you can select a number of parameters. In this case, for this demonstrator, only surface currents are available. After this selection, we are providing information about the availability of data. In this case, you have for HF radar data, the overlap, the spatial overlap percentage, and also the time overlap percentages, and also for the NEMO model. The user then selects this, confirms these choices, and the data is the interaction, the connection to the aggregator is established, and the data is downloaded. After the data is downloaded, in this case, we are downloading the hourly surface currents that are available in the European HF radar node, and we are also accessing, or if this was chosen by the user, daily mean surface currents from the NEMO model that is provided by CMMC. So there is a step of pre-processing in order to assure the compatibility for the purpose of the thematic surface. In this case, by, for example, low-pass filtering the hourly data, and also some gap filling procedures. This is a step that is transparent to the user. And once this step is completed, we then proceed to the presentation of the different tools that can be available. We are proposing two types of exploration of individual data sets: the extraction visualization of the data, in this case for the extraction of fields at selected times that the user can choose, or a time series at a given position that the user also chooses. And we are also proposing in this exploration component the basic statistics for the selected data sets. In this case, we are talking about surface currents, so we are providing the scalar statistics and also vectorial statistics and some of the graphical results that can be associated. And in the integration component menu, we are proposing one integration tool. That's the transport pathway for a passive tracer. We are proposing that the user can select a point, a geographical location in which a passive tracer is inserted, and then and a starting time. And then we are using either NEMO. This is the trajectories that you see in green, or the combination of NEMO model with HF radar current surface currents, where in areas where these HF radar currents are available. You see here the trajectories, and we will also include here surface currents from the HF radar for a specific time, so that we can see the complexity of this coastal ocean environment and why these two perspectives can be important. The thematic service tool, we are dealing with extreme events. We are focusing on impacts that these extreme events can have on the coastal ocean environment. Our strategy here is to select three major storm events that affected this global geographic area, and for each of these three events to provide to the user the relevant data sets for the analysis and integration. You see here the three events. So there are these two storms, Ophelia, Ima, and Hurricane Leslie. And the dashboard environment is the same to provide the interface with the user. The user here only selects a geographical area of interest and the event of interest, and we will propose two integration options. One related to the impacts on the bottom sedimentary cover, and the other impacts on offshore structures. The data sets that we are providing consist of the bottom characterization in terms of the bottom sedimentary cover. Here we are using the ABOTnet seabed substrate Folk 7 product, and also the high resolution bathymetry that is also available from ABOTnet. And for the environmental conditions, we are using the CMEMS wave model, hourly fields of the main wave parameters, and the NEMO model, in this case, the hourly fields of the surface current and barotropic current. So we are using here the barotropic current. We are focusing the impact of these conditions in the shelf, continental shelf, upper slope areas, and we are selecting periods of highest waves and lowest waves. So you can see here the difference in the different from these two periods in terms of significant wave height. The products offered here are a characterization of waving current of bottom sedimentary impacts of waves and currents. The characterization of the shear stresses and critical shear stress for remobilization that are associated with these conditions, evaluation of the characteristics of the bed forms that can be associated with the impact of currents and waves, and also a characterization of the bed load and suspended transport promoted by the waves and currents forcing. The option 2 regards the impacts of the offshore structure, and here we are using part of the results from option 1 in terms of the water column distribution of suspended sediments that can affect, for example, aquacultures, and also the water column dynamics that is promoted by the waves and the currents. In this case, for this thematic service 2, there is a specific feedback that could be interested to have from you. That's the ideas for the extension of this framework to the impacts on the benthic ecosystems. I will now pass to my colleague, Juan Miguel from SOCIB, that is connecting. Can you?
Yes.
Can you connect? Okay. So
yeah.
Go ahead.
Hello, good afternoon. I'm Juan Gabriel Fernández from SOCIB, and I'm going to present thematic service 3, Ocean Glide, the Ocean Glider 1. So the main objective of this service is to showcase the value of Ocean Glider mission, meaning that the main objective is to take advantage of the glider data observations, and ideally through repeated and sustained glider transects. So that way, the quality and the value of the data produced, the advanced data produced, is even better. So you are going to, the idea is that you will produce better coastal information of ocean state and variability. And as you can see in the diagram below, once that you identify one repeated glider transects, then you can use the thematic service 3 and produce both the advanced data products, and also it's important that the methods used to produce the data is in their own an added value outcome of the thematic service. So next slide, please. Joe, can go to the next slide, please. Thank you very much. So how are we going? How are we achieving these main objectives? So the entire thematic service is based on a workflow. You can see in the diagram from left to right that we are implementing 2 workflows that, and it is important to take into account that the second one is in fact already included in the first one. So a user can start either from the first step of on the diagram on the left side, or if it can also start in the second step, provided that the user has a standard NetCDF file with a glider mission. So from left to right, the first step involves uploading Slocum raw data as generated by the glider in the proprietary format of Slocum. The data can be uploaded to the workspace of the user, and then you can start using the pre-processing toolbox that we name a glider converter. and then it uses both the input data and the provided metadata by the users. This pre-processing toolbox generates an ocean glider standard format, which is the new standard format that is going to be incorporated globally for glider data. And then from that step, you can continue the workflow by processing this data set to actually produce the advanced data product, which is a netCDF file containing a gridded data set that include essential ocean variables such as potential temperature, salinity, density, and geostrophic velocity. The processing toolbox also produces some static figures, and then you can access everything in a friendly manner by means of the thematic service Beaver. Then it's important to emphasize that this methodology for producing this advanced graded dataset is entirely based on a recent publication by my colleague Melanie Yusa. Next slide, please. Thank you. So this what I'm showing here is some screenshot of the Jupyter notebooks that you can use in the Jupyter Hub platform provided by Blue Cloud. As you can see here, you will have to deal with how you ingest how you process the raw data from a glider mission to produce the standard format, and then you will have the opportunity to characterize the section of interest in the mission, and then you will process the data to produce the advanced data product. I strongly encourage you to explore the included examples. Next slide, please. Here you can see some screenshots of the interactive Beaver. On the left side, you can explore the outcomes from processing. You can see the detected transits in a specific mission, the plots that has been produced per transect, and also very importantly as well the process information in JSON formats. You can understand or you can explore the different options that you have used for the processing. Next slide, please. Thank you. This is just to showcase how the advanced product looks like. It's a netCDF file that is following the Ocean Glider standard convention. And we have also prepared a manual so you can understand in a very precise manner all the content and all the metadata that is included. Next slide, please. And just for conclude, I would like to summarize that this thematic service is the analysis of seawater conditions from glider observations. The tool has been migrated from MATLAB to Python to foster unrestricted and open collaboration. They are based on Jupyter Notebook, so this allows for the implementation of complex data processing strategies. It fully relies on a standard data set and conventions and formats, so it will facilitate the interoperability and reusability, and it allows to a friendly result exploration by accessing the Beaver. And also the entire service is deployed in an open access cloud platform, which is Blue Cloud, that eventually will be part of the EOS platform. Thank you very much.
Thank you very much, both João and Juan Gabriel. It's impressive work, and I hope that the participants see how important it is to follow these live sessions, preparing them to take on their challenges. It's really great that you also have a manual that will be, of course, part of the resources that we provide to our participants. There is also a very good video that has been created. All of this will be shared. Our coaches and mentors from VLab 1 are going to remain with us along with our colleague Vânia until the end of this session, so we can answer any questions you may have after we finish with all the presentations. Thank you again. And now we're going to go to our next VLab 2 on coastal currents from observations. We have with us Alexander Barth and Abel Dechenne. Thank you again, both of you. I'm going to let you get right onto your presentation.
Yeah, hello everybody. I'm going to share my screen. Nice. Do you see my screen?
Yes.
Okay, perfect. I hope everyone is going great so far. Let me reduce that. Okay, so I'm here to present you the work that we are doing with Alexander Barth on coastal current from observation for the VLab 2. So yeah, I'm going to present you that now. So it's important first to say that we are not working alone on this virtual lab. We are also working with CMCC and with SOCIB. The CMCC is working on the prediction of oil spill model that is collaborative with us. And SOCIB, that is really important for the datasets of HF radar. So we are not alone, even if the work that is presented today is done by us in Liège University, right? So first of all, I will get in touch with the role and the impact of coastal currents. So the coastal currents are super important for many, many reasons. And here I listed some of them. So first of all, the ocean surface currents redistribute heat and salinity all over the ocean, which is super important for pressure fields and for the living organisms, but also influence on the weather. You can think of El Nino phenomenon, etc., that really influence the weather and the raining and stuff like that, but also influence large-scale climate process. Yeah, for sure. You can think, for example, to the Gulf Stream here. It also influences marine ecosystems, the distribution of nutrients that will have blooms. That's why I have put this picture, this really nice picture of the Black Sea here on the right part of the slide to show you an image of a Black Sea bloom in early July 2022 to convince you that the surface currents are really important of the displacement of the nutrients and the distribution of the plankton and the larval dispersion here. It's also important for sure for navigation and shipping, for route planning for the people that are crossing the seas, and for safety and search and rescue, of course. But also, like I was discussing, with oil, for oil spills and debris, or for water quality assessment. Many reasons. You can also have reasons to compute surface current from observation for model validation. So you can compare the observations to the model and maybe assimilate this observation into the modeling to get the model more accurate. But also for engineering application, as you can see here on the right part of the slide, for renewable energy, for underwater turbine, for the management of the sediment transport. Everything is, I want to say to you by that the surface currents are really the root of everything in the dynamics of the ocean. But what are the main drivers of these surface currents? There are a lot of drivers, but here we're trying to focus on the main one, because we're trying to simplify the system to have some equations that we can use. So the currents are generated by various forces, but here are four major of them. So first of all, you have the pressure gradient. Of course, the pressure gradients will create some acceleration and some currents. The pressure gradient is mostly created by heat and by salinity. At larger scales, because the Earth is rotating, you have the Coriolis force that will enter into account for the current that will deviate, of course, the current on the right side, the northern part of the globe, and leftward at the southern part of the globe. You also have the friction. Here is noted in particular at the RC boundary, because the wind is really creating some speed of the currents. But if we are not talking about surface currents, we can also talk about bottom stress, for example, that we slow down the currents at the bottom of the sea. So you have the friction, of course, that here is important, and the gravitational pull. For example, the tides, the moon and the sun tides, that are really important to know more about the dynamics of the flow. So in physical oceanography, we are using the Navier-Stokes equation and specific simplification of the Navier-Stokes equations. And so we have a simplified version that are called primitive equations that are presented here. So yeah, you have the continuity equation that says that everything that is coming to somewhere will exit somewhere else. Here we are not considering the vertical movement of the water since we are taking into account the surface currents. So we are not taking into account dW dz in this equation. And we have the conservation of the momentum that is super important with the acceleration and the tendencies that you can see here in blue. So the variation of u and v velocity according to time. You have also the advection that is greater when it comes to mesoscale and sub-mesoscale sizes. You have the Coriolis force, as I have mentioned earlier, and you have the pressure gradient that is related to the density of the water. And on the black, you have the forcing and the diffusion, and the forcing that are important here in our computations. So our lab is trying to interpolate the surface current to create a product to be used for a monthly product of surface currents coming from observations. So our objective is to derive a graded climatology from in situ and indirect observations. So what does it mean? It means that we have a subset of surface currents that does not cover the whole Mediterranean Sea, and we are going to use this variational analysis to make this graded climatology as it is shown for the temperature here on the slides. So our variational inverse methods aim to derive a continuous field, which is forced by two main things, which are we have to create a graded climatology that is close to the observation. So for example, if you look here at the eastern part of the Mediterranean Sea, you can see that you have mostly observations that are to 39 degrees Celsius. And when it comes to the interpolation, you have here temperature that are still close to 39 degrees Celsius. That's what it means. It has to stay close to the observation. And on top of that, the variational inverse methods try to smooth out the field. It means that you won't have abrupt variation of the field. So here you can see that you cannot range from dark red to blue. It's impossible. You have to smooth out the field because it is like it is in the real life. So here is a case for temperature, but you have to imagine that our lab is doing that for surface currents. Here it is. It's not a simple interpolation as I just shown to you, but we are foreseeing several constraints to compute the surface currents and to interpolate them. So if you want to read more about that, you can go for the paper Barth et al. To 2021. But here I will summarize the constraints. You have the presence of the coastline, so the current cannot go into the coastline. It's really getting the currents to zero nearby the coastline, and you have a constraint of horizontal divergence. So it means that the water cannot just stop, it has to go somewhere else. And with the coastline, you get this kind of plot where the currents is really getting alongside the coastline. On top of that, you have a temporal coherence that is not taken into account in our VLab, but you can use it during the hackathon for sure. The temporal coherence just means that you can force correlation between two time steps of the currents computation. And the fourth one is the momentum balance, which is taking into account the Coriolis force for the computation of the currents. The code is, of course, an open source code, which is implemented in Julia. You can also find a Python version, if I'm not wrong, and everything is on GitHub. So here are the specificities of the DiVA-ND for surface currents. What do we use as a source of observation to reconstruct these surface currents? We are integrating direct and indirect current measurements from different data sources. We have 3 data sources that are shown on the right part of the slide. We have the high frequency radars, which are radars that measure a Doppler shift from the coastline that will show you the currents at 200 kilometers maximum. So it's really antennas on the coastline that are measuring the nearby currents. You also have drifters datasets, like are shown on the right part again, which are deployed in the Mediterranean Sea. You have at some points more than 100 drifters that are floating into the Mediterranean Sea. We are also taking these data into account. And of course, we are taking into account altimetry tracks because we can derive currents from the altimetry track through the geostrophic equilibrium, well known. So once you have an altimetry track, we are able to compute the currents perpendicularly to this altimetry track. Okay, so these are the 3 sources that are implemented in DiVA-ND in order to reconstruct the surface currents of the Mediterranean Sea. So for the hands-on part, how to connect and to prepare the environment for the code to be working and for everything to be set up, when you are on the Blue Clouds page with the virtual labs, of course, you are going for the coastal current from observations. And once you are in the coastal current from observation, you are going in the workspace where you will find a notebook that is called Install VLab 2. And you have a welcome word and everything. And when you will have run these lines, you will get to this. You will have created a folder that is called Coastal Currents Examples, and there you have a surface currents main, and there you have all the results that are already shown. The code is working at this point, and everything is picked up in the dataset. If you want to play yourself with the dataset, they are stored in the folder that is called TMP Blue Cloud 2026, and there you have 1 file for the altimetry, 1 file for the drifters, 1 file for the HF radar, and 1 NC file that is the bathymetry if you want to use it. The code proposes a validation with independent drifters. It means that the code itself is taking it apart, some of the drifters, in order to validate the surface currents that we are computing. So here on the leftmost part of the slide, you have some independent drifters that are not used for the computation of DiVA-ND, but were just set up apart. And these drifters are compared to the results that are giving DiVA-ND. And with this comparison, you will be able to compare the observed V velocities that are belonging to the independent drifters and the interpolated V velocities that are belonging to the DiVA-ND velocities. And this will compare the V velocities observed and interpolated, as well as for the U velocities observed and interpolated. The more you will have a slope that is close to 1, the more you will have accurate reconstruction of the surface currents. So everything here is already available in the code to show you that the reconstruction is pretty correct. And this gives you this kind of results. So you have 1 map per month from 2013 to 2021, which are all validated. You can validate the surface currents for each year. The resolution is 1.4 degree. So it means that it's 111 kilometers divided by 4 for the resolution. And so, like I said, temporal resolution is by month. Here you can clearly see the main patterns of the Mediterranean Sea with the northern currents that is just there, the Algerian currents that is creating a lot of eddies that are not well seen there on this picture. But you also have the Libyan Algerian currents that is just here, the popular eddies that you can find nearby Cyprus, or road gyres or Hierapetra gyres that are well seen here on the picture, as well as the Ionian currents here. So you can really seek for anything on the dataset. Here is a zoom on the eastern part of the Mediterranean Sea, and also are computed in the codes the eddy kinetic energy. So for an example, I was talking about the Algerian currents and the created eddies that are linked to these currents. If you watch here for June 2018, you can see that the eddy kinetic energy is pretty high, and everything, once again, is computed in the notebook. You can adjust the month and the year that you want to compute, but everything is automatically done. And there you have also the mean kinetic energy for the whole 2021 year. That is showing us here that the northern currents is the strongest currents here. And here the Sicily Channel that has also high kinetic energy. And you can see here the main path of the currents in the eastern part of the Mediterranean Sea. So it's like the playground is large. You can seek for anything you want. Everything is already computed in the notebook. You just have to tune the year and the month. Of course, if you need some help, I will be there on Discord to help you for everything. And that's it for our part of the VLab. Thank you.
Thank you very much, Abel and Alexander as well. This was, again, excellent work. And thank you also for reminding us. There's so much expertise packed in the Blue Cloud project. There are so many partners from around Europe that are taking part, and actually also beyond, creating all of these resources for you. Great PowerPoint. It will also be added to the resources. I think you're taking participants step by step through how they can work and why they need to work with VLab 2. Thank you. And Abel and Alexander will both also be with us to answer any potential questions you might have at the end of this session.
Yeah,
so we're doing very good on time also. Thank you, Abel. And we're going to go to VLab number 3 now. And we are going to welcome Cyrielle Delvenne and Matteo Bazzaro. We're going to present you with VLab 3, the Carbon-Plankton dynamics. Over to you both. Thank you very much.
Thank you, Angeliki. And hi, everyone. It's great to be here. So I'm Cyrielle Delvenne from VLIZ, and I'll present this VLab together with Matteo Bazzaro from AGS. So if you move one slide, you'll see that I'm giving credits to all the researchers that have been involved in this VLab. So Stephen Pint created this VLab, and then it was then implemented together by VLIZ and AGS together with researchers such as Matteo, that's today with us, Gian Piero, Frederica, and then Tom Van Engelen by VLIZ also created an R Shiny app focused on carbon. So you don't see my name there because I'm not one of the researchers, but I'm very happy to replace Stephen to present this VLab. And please ask any questions if you do have them, and I can always go back to him in case I cannot answer them. This VLab, as it says, is about carbon and plankton. So what we do is really to try to understand better all the phytoplankton dynamics in different marine settings, different biomass variability, and really how it interacts with nutrients, phytoplankton, zooplankton, and detritus. The model that we created focuses on the Belgian part of the North Sea, so the southern North Sea and the northern Adriatic Sea. The northern Adriatic Sea, Matteo will give you more explanation about it, and I'll just walk you through the model and what the VLab includes as a whole. So the model is a NPZ model, so it's nutrient, phytoplankton, zooplankton, detritus, mechanistical models that runs in carbon units. And if we move on one slide, thank you. You'll see that the goal of the VLab is really to integrate different data types to better understand every of these interactions. The data that we need to use this model. And I emphasize this because obviously we provide data for the Belgian part of the North Sea and for the Adriatic Sea, but you can use it in any place, any part of the ocean. But you obviously need some data inputs that you can find through our DDAS. So that's the Data Discovery and Access Service that we provide through Blue Cloud. I think you'll have an introduction to that service in a few days. But from there, or if you have your own data as well, you will probably need sea surface temperature, salinity, nutrient concentrations, and also carbon-related variables like atmospheric carbon dioxide, wind speeds, and pH to be able to run this model in VLab 3. So why do we do that? Well, to identify the drivers of plankton dynamics and the carbon fluxes in the ocean. If you move on one slide, thank you. This VLab is available as a Jupyter notebook that runs on specific servers with the required R libraries. Everything's already pre-installed, and that's why it's so easy to use for you. And the VLab is, as I said, very easy to use because it really walks you through every step of the notebook. So even if you have very basic knowledge of R, of Jupyter, this was really made to make it easy for you. So we can go on one slide, thank you. When you'll have access to your slides, you'll see all the steps, but we also provide an Ocean Teacher Global Academy course. I'll share the links after in the chat. And if you do the courses, then we'll really explain every step of the model and how you can make it work with your own data as well. So I won't present it in this presentation, but we do have a lot of resources for you to be able to use the VLab. But this is the kind of outputs that you could get if you do it, for example, for the Belgian part of the North Sea. You will see all the relative contributions of every of these drivers. So nutrients, zooplankton, sea surface temperature, and you can see the impact it has on carbon fluxes. You can move one slide, thank you. Obviously, we do this in the frame of the hackathon, which is very exciting. So I just wanted to share some suggestions with you about VLab 3. I think VLab 3 can really be used as a collaborative workflows because it's an R script, Jupyter notebooks that you can improve or that you can use with your own data, or that you can do so many things with it, and it's so easy to work together on the same server. This VLab is running both in Blue Cloud 2026 and Editor, so it's the perfect example for Challenge 4, for example, if you're still looking for some ideas. And obviously you can use this workflow to try to estimate the ocean carbon uptake, which is quite a big challenge, because here, as you understood, we're really focusing in local areas, but up to you to try to scale it up. But you can also use it for citizen science or education and outreach. That would be a total different angle, different total point of view to really explain, maybe in an easier way, the link between plankton and carbon uptake. Because carbon cycle is always super important for the ocean, but also for just life in general. So if you use this VLab, that could also be a nice way to just kind of make it easier for everyone to understand it. So these are just a few ideas from my side. And now I'll leave the floor to Matteo, our expert from OGS, who's gonna explain more about the Adriatic Sea. Thank you very much.
Thank you very much, Cyrielle. I'll try to share my screen. I hope you can see it.
Yes.
Yes.
Okay, thank you very much. So, Cyrielle give you a bit of suggestions. I instead will give a bit of options to how to use the VLab 3 during the hackathon and to face actually the hackathon challenges. So you basically have three options. One, the first, using the data from the Belgian North Sea, and so use that as your case study. Another one is vice versa, is to use the data from the Adriatic Sea. Otherwise, you can also use your own data set, but you have to remember to recalibrate the model with several parameters. But since I'm a researcher of the audience and our main buildings and laboratories are directly on the Northern Adriatic Sea, I'll give you a bit of background, about the Northern Adriatic Sea case study. So I'll give you a quick introduction about the area, but the aim of my presentation is also to give you an idea of how big and robust your own data set should be in order to obtain a realistic output from the model. So this is the study area, so the Northern Adriatic Sea. And here on the left, you see the parameters, the input parameters and the calibration parameters we employed for the VLab. So the inputs are temperature, salinity, and nutrients taken from the station C1, which is a long-term ecological reserve station. Whereas for the calibration parameter, we chose the chlorophyll A and the phytoplankton abundances always from the C1 station. And instead, we collected carbon data and PaCO2 in the seawater from a buoy located in the middle of the Gulf. The C1 station is located at the boundary of the marine protected area of Miramare, which is delimited by several buoys. And the one you see is the left, is the actual where the C1 station is located. So you see that we have a good site on the Miramare Castle when we sampled. And right this morning, by chance, I was there for the monthly sampling that we perform on this station. So C1 is a really coastal station. You see the depth is quite low, 17 meters, located 200 meters from the coast. Since 1986 initialization was measured, collected biological time series by the Laboratory of Marine Biology of Trieste, but since 2005, the time series and the station were handled by the OGS. In this station, we collect several biogeochemical and biological and physical parameters, once per month, at several discrete depths. So you see 0.5 meter, 5, 10, and 15 meter below sea level. This is quite important for even for the model, because you have to remember that when you use the VLab, you will have to select the depth at which you want to use your model actually. So even in the case you prepare your own data set, be aware of the many sampling and discrete depths that you're going to use. Okay, again, the Gulf, here you have quite a lot, maybe too many information about it, but I think, again, that it could be useful if you decide to use the Northern Adriatic Sea case studies for the hackathon. So again, you see a really shallow basin and semi-enclosed basin with quite a big range of salinity and temperature, with persistent water column stratification almost persistent during summer, well mixed during winter, and generally characterized by the cyclonic circulation. You see that salinity can be quite low, and this is because if you take a look at the map, you will see that there are several rivers all around the area. The main one is located northwestern of the Gulf, is called the Isonzo, and in occasion of the biggest floods event, its plume can even reach the C1 station that you see depicted in the area. So there are several natural forcing that affect this small gulf, so the river and also the groundwater discharge, because, for example, one of the rivers, the Timavo, has also several underwater springs that affect all the northern boundary of the Gulf. And obviously, the nutrient inputs, the precipitation, and also the wind regime. We have two main winds affecting the area, the Bora blowing from the northeastern and the Sirocco from the southeastern. These are, I mean, the forces, the natural forces affecting the Gulf. But also, as you can imagine, there are several anthropogenic pressure from maritime transport, harbors, mussel and fish farming, fishing, recreational activity, and also human waste discharge. Because if again you take a look at the map, you will see there are several orange lines, which are the pipelines of the inland wastewater and treatment plant. There are 9 depicted in this image. Actually, the number 5 is dismissed. But that you see that the number 4 is quite near the C1 station, and actually OGS since 2016 is actively involved in the monitoring of this pipeline. But we have also some extreme events in this area. For example, there were several episodes of hypoxia, in particular during the 90s, but the frequencies decreased during the years, as you can see from the graph. And another interesting thing are the mucilage events that again characterized in particular the 90s and even the first year of the 2000s. And this picture actually was taken last summer, so 2024, when this massive mucilage event that affected all the Gulf, but also the entire Northern Adriatic Sea for the whole summer. So taking a look at the parameters that you are going to, the input parameters for the VLab. Here are the nutrients. Okay, here you see the entire biological time series covering, in this case, the year from 1986 to 2018. In the model, you will find in the VLab 3, you will find a portion of this series covering the years from 2011 to 2020. You will see that the silicates and the solid organic nitrogen remain with their internal fluctuation more or less the same over the year, but there was quite a huge decrease of phosphate after the 90s. And this is mainly the results of the European Union directives that limited the use of fertilizer in agriculture just during the 90s. On the right, you have the river loads and the precipitation, and you see on the entire area, and you see there is quite a good agreement between these two parameters. Chlorophyll for the VLab is another calibration parameter you have to put in. That, because you can see displayed more or less the same and the same trend of the phosphates. So quite a huge, but high, let's say, concentration during the 90s, and as likely in this case decrease during the 2000s. Phytoplankton. Here you can recognize 3 distinct patterns. I want to clarify this. The graphs on the middle are referred to data collected all over the Gulf of Trieste, while the plot on the left and on the right, they are referred respectively to the interval 1986-2010 and to the other interval 2010-2018, are specifically referred to the C1 station. So what you notice from this slide is that the phytoplankton internal variability has 3 distinct periods. One covering the years 1986-1984, when there were the highest abundance of phytoplankton, with microalgae and phytoflagellates among the dominant organisms. Then the second period was between 1995 and 2007, with lower abundances and a collapse of the phytoflagellates. And the third period, starting 2008 until now, where there is a constant increase again of the phytoplankton abundance. If we take instead a look at the seasonal variability of the phytoplankton, as you can imagine, the cycle of this organism is, even in this area, influenced by temperature, salinity, and particular nutrients inputs. So there is, in general, a bloom in spring, a peak in May, decrease in summer, and another increase in October, and followed by the winter minimum. I would like to end the presentation just to show you what is the data flow of the biogeochemical and the biological data that we collect in C1 and in general in the Gulf. All the data are managed by the OGS and AODC, which is the National Oceanographic Data Center. And the biogeochemical data are managed according to the C.NET and Emodent chemistry standard. And all the data are available through the OGS and ODC or through the Emodent chemistry portal upon request in case of restricted data. And similarly, the biodiversity data flow are managed by the OGS and ODC, but in this case are managed according to standard of Eurobis and Emodent biology. Again, all the data are open access through the OGS and ODC portal and Emodent biology, but for those restricted, in the case you have to send a request to the NODC. So here is just a list of the references that I use for the presentation and others that you can find useful for the hackathon challenges if you choose the Northern Hidrografic case study. And if there is any question, Cyrielle and I will be happy to respond.
Thank you very much, Matteo and Cyrielle. It's incredible work. And it also, I think that those who have followed also the previous live session can already start seeing what our presenter meant when we were giving the inspirational talk about why the ocean matters and why did we choose these challenges. And you can see a lot of them already reflected in the VLabs that Blue Cloud has been creating that aim to address real issues in society. So this is really incredible. Thank you both. And we are going to, we will still have you with us until the end in case any questions arise. Thank you for staying. We will go now to the next VLab, VLab number 4, which is the marine environmental indicators. This is going to be presented by our colleague, Francesco Palermo. Welcome, Francesco. Thank you for joining. I'm going to give you the floor.
Thank you, everyone. I'm Francesco Palermo from CMCC. I'm going to show you my few slides. Okay, and then I go with the presentation of the VLab. Okay, I guess you can see them.
Yes.
Oh, yeah. So just a few slides to present this VLab 4 called Marine Environmental Indicators, because this VLab offers you the possibility to use some tools we developed for assessing the environmental status of marine areas. So we provide some algorithms for obtaining information about ocean indicators. Here you can find the list of the participants at this VLab, some partner along CMCC, so ENGV with Simona Simoncelli and Enrico Baglione, OGS with Alessandra Giorgetti, Catalina Ries Suarez, and in the CMCC team, there are also Fabrizio Antonio, Ronan McAdam, and Rafael Meneses. Just to show you that we are able now to produce in the with the VLab these three new indicators, because the VLab was already present in the first phase of Blue Cloud, so other indicators are already available. But in the Blue Cloud 2026, we are working on the oceanic content with the ENGV, trophic index, TRIX, with the OGS, and marine heat waves in CMCC. On the VLab homepage, you can find all the information needed for using that. All the documentation, the how-tos, the handbooks, and the tools. And there is also the web app that we are going to develop, not yet completed, and all the notebooks available. Now I connect to the VLab directly. Can you yet see the screen? Okay, I'm on the Blue Cloud homepage. Can you see that?
Yes, Francesco, all good.
Okay. So on the center of the page, you see the list of the VLabs. Here you can find our marine environmental indicators, but I suggest you to go to the top right menu and to find the links for all the VLabs, and then click on the marine environmental indicators. Here you can find a list, a short description of the VLab, and all the information you need for accessing the indicators. I mean, the tools we have that are in the form of notebooks. Here you can find also the links for accessing the handbook that contains all the information about even the other VLabs, and all the scientific description also, and the instruction for using, in our case, the notebooks. Consider that there are available very short how-tos that can help you to understand how to run the notebooks. So let me open one of those. I suggest to open it in another tab. Yes, because we go back then in the previous tab for running the Jupyter. So in the how-tos, you can find the very short introduction to the notebooks and the simple instruction for installing it. I want to show you how to install each notebooks. It's very easy to do that because they are in the zip archive, and you have to run these two commands in the terminal and the Jupyter Lab. So we will do that now. Go back on the virtual lab homepage and start the Jupyter Lab. I already installed all the notebooks here, but I want to show how you can do that. So here the Jupyter Lab is started. Click on File in the Jupyter Lab menu. Click File, New, and select New Terminal. In this way, you can go back to the How to tab. You can run this very simple command. So copy the command and run it on the terminal. And this is just a zip archive, so you can do an unzip for it. And this is the way all the notebook will work, will be installed. I already did it, so I don't need to do it again, but if you list the files, they are all here. And when you uncompress the files, you will find on the file manager on the left, the new folders that are MHW for marine waves, OHC for ocean contents, and TRIX in the case of the TRIX, where you can find the notebooks. Let's see the notebooks for marine heat waves. There are two. One for the maps. It's very easy to use. Just a few words about the marine heat waves. They are prolonged periods of anomalously high sea surface temperature that may have significant impact on marine ecosystems, biodiversity, and socio-economic activities. After this short introduction, you can read it, but also you can find more on the handbook, even the references. there are the cell for running the code. I already run it, so I don't run it again, but I want just to say that we used for that sea surface temperature satellite data from CMMs in reprocessed data that starts in 1982, or near real-time data satellite started in 2008. So you have a drop-down for selecting them. And then you can do the query, etc., and select the data of your interest. For the maps, you can select just one day. I selected the 30th of August, last August. You can even select the region of your interest. And then you can run the cell that process and filter the data. At the end, you will have this PNG that represents the area you selected, the day you selected for the temperature anomalies. The second notebook done by us, by CMCC, it's even related with marine heat waves, but with this second one, you can generate the time series. So the dataset used are the same from CMMs, satellite data. And in this case, you can select some predefined regions, because in the first one, you selected only an area. You can do that also in this notebook, but in this one, you can select a predefined region. You can select a data range. I choose from the 1st of May to the 31st of last July. And as a region, I selected the Adriatic Sea, but you can, this is the list, you can choose other one. This is a preview of the sub-region of the Mediterranean Sea you have selected. And after the filtering of data computation, you will have at the end the time series that show you what was the situation for marine heat waves in the period considered. Okay. I go now to the ocean heat content notebook. The ocean heat content is another very important ocean monitor indicator because it offered a way for understanding the ocean warming, what's happening with the ocean warming due to climate change. And about 19% of the excess heat accumulated in the Earth system is deposited in the world's ocean. And the Earth energy imbalance causes rising ocean temperatures and increasing ocean heat content. In this case, we are yet considering marine heat, the Mediterranean Sea. And you can read here a short description and a mathematical definition of the ocean heat content. The data used are from CDataNet and Siemens Cora. They were integrated with the DivaMT tool to obtain temperature gridded fields between the surface and the 2000 meters of depth. From these gridded files, the OHC anomaly time series and trends were computed in the latter layers of 700 meters. The data used in this notebook are already available on the data space, but in the future they will use the data from Beacon. Okay, so in this cells you can find information about the metadata. There are a few cells for describing all the information needed for running the notebook, and many information about the validation for obtain some information of what how is running the notebook. Some commands that you can use, I mean, some parameters that you can change are the longitude and latitude range and the time range. Even the depth can be changed. I want to say that please consider that the notebooks are in ongoing stage and are in development. So don't be afraid to find some errors or even bugs. It can happen. We are sorry for that, but please, you can suggest us if you find them. It will be very useful for us. So after loading the map and cutting that, you can obtain some new plot, a few plot for, as I said, for validating the data you are using. There are a few. You can go down. This is already run. You see all the images already prepared. And there are different plots that can help you to understand what data you're managing. This is for the temperature in the very long time range that is available in the data source. There is also a Hofmöller plot. And finally, we are able to compute the oceanic content main outputs that are the temperature anomaly profile. This is the time series. And the last one is the oceanic content anomaly in the region selected by the user, so from 0 to 2000, and the entire period of the input data source. At the end, you can also have the NetCDF dataset if you want to use the data in NetCDF format. NetCDF is also available for the marine heat waves. The last indicator I want to show you is the notebook. TRIX is the trophic state index. Depends on the availability of nitrogen and phosphorus for primary production, which in turn determines the phytoplankton biomass and oxygen saturation. So it's very important. You can find here some information about the notebooks as always, and the dataset, even in this case, are on Blue Cloud, so already available. You have to, there is a preparation of the dataset used by the notebook. There is the filtering, and at the end, following that, the TRIX calculation with even, you can find here some formulas for describing it. At the interface, there is also a small interface, user interface. Oh, sorry. About for visualizing the result of the TRIX. In fact, there is here a map where you can zoom in and go around to see. If you put the mouse on the points, you can even see the values. There are some parameters that you can change, that the season, because the TRIX is related to the season that calculated here. And also you can change the depth with this other slider. Okay, so it's very easy to interact with these notebooks. If you have any questions, please let us know. We are available for give you more information. Anyway, take a look to the documentation available on the VLab and enjoy.
Mm-hmm.
Thank you.
Thank you so much, Francesco. I also hope they will enjoy, indeed, and it's a great thing, of course, for participants to see the platform in action. So that was this was also a great opportunity for them. And thank you also for pointing it out. We did mention it in the previous session, but it is one of our main goals. So it bears repeating that we have invited all participants to help us improve possibly any aspects of the work that is being done so far by the Blue Cloud project. So indeed, you're going to see that also in the deliverables and in the questionnaires that we will send after the hackathon, we are asking for your feedback in all of our services. And it's always a great reminder. Indeed, a lot of the resources we have are in development, will be in development as technology also changes and allow us to do so. Thank you very much, Francesco. Francesco will be with us. He will also be supporting you during the hackathon itself. And now we are going to go to Julien, Barth, and VLab 5. This is a global fisheries atlas. Thank you very much, Julien, for joining us.
Yes, thank
and
you.
giving
Can
you
I
the
share my
floor.
screen? Yes.
Absolutely.
So let me share my screen. Okay.
Great. Yeah, we can see it.
Okay, so good afternoon, depending on where you live. Can you see my screen? I'm not sure. I'm sorry to ask again. Yes. So I'm going to present the last VLab, Global Fisheries Atlas Virtual Laboratory. So my name is Julien Barth. I'm working for IRD, and that's a work that has been achieved with my colleague Bastien Grasset and Yanis Marketakis from Force in Crete. So just to give you a quick overview of what you can get in terms of data from this VLab, we generate global data products reflecting the activities of fisheries and focusing in particular on the case of tuna fisheries data. So here you can see the mean annual distribution of some major tuna species worldwide from 2005 to 2015. So this is the kind of product or map you can generate from the data we generate in this VLab. And it is called the Global Tuna Atlas. And you have also in this VLab another source of data, or rather knowledge, a knowledge base that is called the Global Records of Stocks and Fisheries. And it gives you unique identifiers for all the resources that are related to fisheries, meaning stocks, fisheries, species, fishing gears, water areas, flag states, and also a source of time series data that are related to those fisheries. So this is basically what we generate. You have some courses that will be published to help you explore the content of this virtual laboratory. So courses for both Tuna Atlas part and Global Records of Stocks and Fisheries. So this is online, and this is some very valuable source of information if you want to understand how we generate these data sets. But if you are more focusing on the tuna data products, I would encourage you to look at the elaborated products that are available in the virtual lab and published on Zenodo, meaning we assign DOIs to this data set. So you have different data sets, meaning they have different spatio-temporal resolutions. Some are at the level of the oceans with a yearly temporal resolution. Some others have a higher resolution from 5 to 1 degree for the spatial resolution with a monthly temporal resolution. So this is listed here on this slide, and I will show you how you can see the very same information on the homepage of the VLab. And same for the Global Records of Stocks and Fisheries knowledge base. In the VLab, you will have different ways to access and browse the content of this knowledge base, either by an API or a Sparkle endpoint for those who know the semantic web technologies. So I will show you a bit more directly in the VLab. Here at the bottom, you have some screenshots of the different ways to explore the content of either data or knowledge base. So also what we did, because we need this actually to have some checks, running some quality controls on the data sets we generate. So we have some Shiny apps that are dedicated to explore the data we generate. And also a map viewer to explore the content of the global records of stocks and fisheries. So it's interesting because this code generates plots, maps, charts. So you have chunks of codes there that can be reused to be customized or elaborate totally new products. So it's important noticing that it's running in the VLab, either as from our studio server or directly graphically by visualizing the app in a Shiny proxy server. The code is available on GitHub, meaning that you can access, have full access to the code. And also for the R programming part, it's important to notice that we use a R-env package, meaning that we have snapshots of the virtual environments that we use that you can reproduce if you need to in the VLab to ensure that you can reproduce the work, which is of course one of the major goals of the Blue Cloud project, since it's focusing on open science. So additional resources here. You have some dynamic reports that are in the OTGA courses that will help you to start playing with the data or understand how you can configure the virtual environments in RStudio if you want to reproduce or customize the work. You have also some very valuable information in the firm's website that is hosted by FAO, where you have like a complete description of what we do. If you want to focus first on the data, I will advise to read the metadata, of course, that is attached to the dataset published on Zenodo. Play a bit with the Shiny apps if you want. And of course, you can contact the three of us, myself, Bastien, and Yanis, if you have some questions. So what I suggest now is just to show you a quick overview of how it looks like once you have signed in the Global Fisheries Atlas virtual lab. So this is the welcome page where actually you will get like the same information, access to the GRSF API, Sparkle endpoint, dashboard. So you have links that you can click to access the different applications in the VLab. Same for the Shiny apps here. If you click on the screenshots here, you will launch the Shiny apps. It's a bit slow, but it's for research purpose. So it's running behind the scenes some filtering on quite heavy data sets. So just to warn you, it's a bit slower than you would expect probably. And here you have like the DOIs of the data sets that are published on Zenodo. You have here the GitHub repositories where you can find the code. And if you click here, just like in the other VLabs, you can access RStudio mainly. We don't use that much Jupyter Lab, but it's the same, let's say. And here you have like items menu where you can find like the different applications I was mentioning. So it's worth noticing also that we've been working with the colleagues of CNR running this infrastructure so that every newcomer can get some of our GitHub repositories pre-installed in RStudio, meaning that it should be quick for you to just replicate the very same running environment as the one we used. So if you have like issues, of course, we will be glad to hear about this and help fix the issues if this is the case. So I'm not going to detail like the whole Shiny apps and everything, but I will stop here. And if you have some question, I will be glad to reply later on. So thanks for everything, and I'm done for my part at at this stage.
Thank you very much, Julien. You gave us the best of both worlds. We have the benefit of your presentation, but also what it actually looks like on the platform and what participants are going to be seeing when that moment comes. Also, it was good. I'll take the opportunity to mention, because you said something about the training academies or TGA. Indeed, this is another section that will be included in your hack pack, and you're going to have the opportunity of using that as a resource as well. So I believe now we have presented all 5 of our VLabs, of the Blue Cloud 2026 VLabs. I'm not sure that, so it was very good presentations. We don't have any questions on the presentations themselves, but Michele, we could go to our Q&A, perhaps if we could open, if everyone could open their camera as well.
Yes. So you have the Q&A functionality to ask any question if you wish. And while maybe you think about your question, I would like to maybe go to Discord for a second to anticipate how the support process from the coaches and mentors would be. You're not still able to see these channels here, the coaches channels and the challenges channels, but these are the places where you will have all the coaches and mentors. Some of them were the speaker today and on live session 1. So basically, this channel will become public. You will be added here, and you will be able, for example, to write a message to Juan Gabriel for VLab 1 or for the other virtual labs. So this will be the place. We are preparing this. And in the next days, maybe next week, it will be already available for you. The same thing is going to happen for the challenges. So we will have one channel for each one of the challenges. And then in there, you will have a challenge leader, and you will be able to share your questions there. And the challenge leader will be in charge of redirecting those questions to the right coach or to the right mentor. So this is the process that we have right now. Again, for now are not visible, but you will see them in a second, and you will also be notified, as I always do, on the announcement channel, so you will know when it's available. I just wanted to share this. So in case you have any question, please use the Q&As. Usually, Angeliki, when we don't have a question, is because the speakers were very, very clear, right?
But I will take the opportunity now. I have a question that might be useful to participants. As we have in some occasions asked them, I think, to combine VLabs. Is there anyone who would like to take on these questions? How does that, is there specific VLabs they can combine? Is there a limit to this? Is there anyone who would like to tell us a little bit about that? Okay, it's something that we will be covering, I think, also in our live session number 3 about this type of combination. I do not see any Q&A here, but again, as we had mentioned, they can also put their questions directly into the Event Tornado platform, and they will receive their answers there in due course, and when our coaches and mentors can get to them. So as usual, we're not going to keep you longer than needed. We have gone through the material that we want you to be aware of, the type of resources that you're going to have to familiarize yourself in the next almost 2 weeks that we still have until we actually launch the hackathon itself. So there's still a little bit of time. We are going to be uploading this video along with all the resources that the coaches and mentors have created for it on the platform, so you can take a look. And I'm going to thank all of you very, very much for joining us, for all the work that you have been doing on a voluntary basis in order to support our participants. As we said, we now have almost 70 teams that are going to be competing in this hackathon. So let me very quickly see. We do have one question before we go from one of our attendees that says the requirement is that resources from a minimum of 2 VLabs or workbenches should be used for all solutions. Yes, and that is the case. You do need to use at least two resources. But again, this is something that is going to be addressed extensively in our upcoming sessions next week, and we will go a little bit deeper into it. And then I see that there is another question. I don't know if any of the coaches we have can also see it. It is a bit lengthy. I'm writing to report an issue that was encountered while setting up the phytoplankton EOV project in their personal workspace on the Blue Cloud VRE. There is an explanation about the process that was used. I used the copy files phyto script to duplicate the project to my home directory. The script successfully copied the chia product and PFT product folders, but the crucial input folder was not included as the copy. I think that this is a question that, again, it's a bit longer. I don't know if someone wants to take it on now. Otherwise, we're going to add it to into Event Tornado directly and provide an answer for you there. This needs a little, yeah.
If
Please.
I can, I think that the questions is not oriented on the VLabs, but on a workbench.
Okay.
Because I read the essential ocean variable, and so I think it's for a workbench.
Okay.
Yes.
Great. Thank you. And workbenches, I believe, are indeed covered in the live session number 3. We are going to discuss workbenches, EOV workbenches for electrification and many others. So this is a question that will definitely be answered there, but we will keep it on file to make sure that by the end of our warm-up sessions, it will have been answered and you will be able to move on with the hackathon and use the resources you need to. So again, thank you so much. We are going to, oh, I'm sorry, I wasn't expecting it. Are we allowed to include external sources as long as we use the minimum of 2 VLabs? I can answer that actually. We have not put restrictions on the resources that you're going to be using. As you see, Blue Cloud, the Blue Cloud project itself is using a variety of data resources. So as long as it is compatible and as long as you can identify it correctly on your solution, yes, then of course it's going to be possible. Okay. I'm going to give the floor then to Michele, who is going to tell you about the next steps before we go. And we look forward to seeing you next week, as we have now already covered all the VLabs. I've given you some explanation as to why we're doing this hackathon and what ocean best practices are that we're looking for you to apply also in your solutions. Have a great afternoon. Michele, over to you.
Thank you so much, Angeliki. So yes, as you was mentioning regarding the question of the attendees, the next one, the live session number 3, is the one about the workbenches, the data discovery and access services and the beacon. So in here, it will be the time for you, as you can see at the end, we have the Q&As. That will be the time for that question. I also shared it with the coaches and mentors in our channel that we have. So we hope to come back with an answer soon. And then we have the live session number 3 is on the 23rd of September, which is Tuesday. And then we have the last one, which is the day after on Wednesday, the live session number 4, which will be all about the hackathon challenges. So in there, we will provide you all the information about each one of the challenges. And again, any question that you have, you can go to Discord. That's the only place to reach out to us. main place. And again, thank you so much for the live session. Thank you so much to all the speakers. They were great. Yeah. Thank you.
Thank you. See you next week. Bye.
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 See you. Bye. Thank you.